Hi everyone, welcome to AWS ASEAN Summit 2022. Thank you for joining our session. My name is Julia and I'm a solutions architect at AWS focused on digital native customers. For today's session, I'll be joined by my colleague Wei Liang. Together, we'll be showing you how you can easily use machine learning to combat COVID-19 related misinformation using AWS Artificial Intelligence or AI services. We will start off by examining the problem statement before diving in to create a machine learning model. After that, we'll look at how it can be integrated into applications that users can interact with to determine the authenticity of COVID-19 related news. Let's begin by examining the motivation behind the solution. As more people use the internet, exchanging information with one another using social media and messaging platforms, it becomes harder for us to distinguish between what's authentic and what's not. When we come across a new piece of information, how do we know if the information that we get from one another is actually trustworthy and not hearsay? What if you can create a bot that can help to clear your doubts? Helping people to discern between authentic and sensationalized news is important to ease tensions, improve the sentiment of the masses, and to accelerate the return to normalcy. Today, we present a simple solution that allows you to create a bot that utilizes machine learning to indicate COVID-19 related misinformation. To break things down, this is a problem in the domain of natural language processing, or NLP for short. NLP problems often require elaborate steps of data preprocessing so that machine learning algorithms can better utilize the data. This includes techniques like tokenizing words, extracting word stems, and removing stop words. Additionally, since words and phrases relate with one another in a complex manner, NLP also usually involves the use of elaborate neural networks. What we want to do for this use case is to categorize short utterances or snippets of natural text into two categories, those that are authentic and those that are not. In our solution, you can do this very easily using AWS AI services without having a background in machine learning. And you don't have to write any machine learning scripts, create any neural networks, or perform model tuning. At AWS, we have a service called Amazon Comprehend. It is an NLP service that discovers insights from text with capabilities including entity recognition, classification, topic modeling, sentiment analysis, and more. In our case, we'll use it for classifying text. Let's begin by creating and deploying the model. To coordinate the different steps, you can manually perform the individual steps using the console, or create automated workflows using Amazon Comprehend's APIs. One way that it can be automated is to use Jupyter Notebooks launched using Amazon SageMaker Studio. To give some context, Amazon SageMaker is our machine learning offering, which includes tools that range the entire machine learning workflow, including a web-based integrated development environment, or IDE, named SageMaker Studio. The first step to create a model is to prepare the training data, which should be stored in Amazon S3. S3 is a cost-effective option for storing large amounts of training data. The data input requirement for Amazon Comprehend is a CSV file containing just 2 columns with the labels and the text without any headers. For repeated training workflows, an ETL pipeline can be used to convert the data to the required format and store the training data in S3 for Amazon Comprehend to pick up. Next, we'll use Amazon Comprehend to train a classification model. In our case, this is a binary classification problem, which means that you are classifying text into 2 classes. For Amazon Comprehend to access the data in S3, you need to authorize Amazon Comprehend to interact with your S3 buckets. You will need to create an IAM role in your AWS account with the relevant permissions to access S3 and trust policies that allow Amazon Comprehend to assume the role. Once the model has been trained, we have 2 methods to interact with it. We can either create a job to generate predictions by batches, or create an endpoint to serve real-time predictions. When an endpoint is created, it can be used to serve requests as part of your applications through API calls. Let us take a look at how this works. We'll be using SageMaker Studio IDE to coordinate the multiple steps. To start creating the model, we utilize an open dataset of COVID-related tweets that have already been labeled according to two categories, real and fake. Let us load and examine the data. Since the data is rather clean and balanced, we do not have to perform much pre-processing. After performing randomization and converting the data to meet Amazon Comprehend's requirements, we send the data to S3. Next, we create an IAM role for Amazon Comprehend to access the S3 bucket containing the training data. Now we can specify the classifier's details and commence training for the classifier. When Amazon Comprehend has completed training, we can review the model performance. We'll take a look at this on the Amazon Comprehend console. We'll select the version that we have just created to view its performance. Amazon Comprehend provides you with metrics that estimate how well your classifier will work. We observe good scores for metrics including accuracy, F1 score, and so on, which indicate how well the model discerns between classes. Next, we can deploy an endpoint to host the model. Now that we have our endpoint, we can make API calls to obtain predictions. We'll use the labeled test data to run some predictions and obtain some metrics. This dataset is quite evenly distributed as well. Using two sample sentences, we'll take a look at how this endpoint works. We observe that the JSON response returned from the endpoint will provide the most probable class first, along with the confidence score. Next, using the entire test dataset, we will create an asynchronous classification job to obtain predictions. We will have to convert the data to the format that's required for asynchronous classification jobs. With that, we will start the job. Let's examine the results of the classification job. We will first have to download the file from S3 and extract its contents. Next, we will concatenate these predictions with the original test dataset to compare the predicted label versus the actual label. This is how it looks like. Now let's plot a confusion matrix to visualize the results. We can see that there is good separation between classes. In the top left, we have what's classified correctly as fake, and in the bottom right, we have what's classified correctly as real. In the top right, we have tweets that should be classified as fake but were classified as real, and in the bottom left are those that should be classified as real but were classified as fake. Let's calculate some scores using the predictions made on the test dataset to see how well we have identified what is fake versus what is real. Take note that if you create your own model, the numbers that you get can vary because of randomness. With that, I will now pass the time to Wei Liang, who will show you how to apply the output model in applications that people can interact with to find out if information is trustworthy.
Thank you, Julia. Hi everyone, my name is Wei Liang and I'm a solutions architect at AWS focusing on public sector customers. I'll be taking over the second part of this session where we can look into how we can implement the classifier. This slide shows some of the ways that we can integrate Amazon Comprehend API which will interact with the endpoint that we have just created. For example, the API can be called to flag out posts on social media that could be unauthentic, so that the users can verify the authenticity of news before sharing them. Another example is using the API in a chat plugin to warn users to verify information before forwarding messages that are predicted to be unauthentic. Finally, one of the ways that it can be integrated is using a chatbot. AWS has an AI-powered chatbot service called Amazon Lex, which allows users to build conversational interfaces into any application using voice and text, allowing you to add natural language chatbot quickly and easily. In the next part of our demo, we will show you how you can integrate Amazon Comprehend API with Amazon Lex using our AWS Lambda, which is our serverless service that can be used to integrate with other backend AWS services. From the left side of the slide, you can view a sample conversation with the chatbot where the blue box represents an utterance, which is a user input that triggers an action configured for a bot. This action will trigger a backend Lambda function that makes use of general AWS Python SDK to easily integrate your Python application, library, or script with AWS services, which you can see in the code example. So there are two main components. One is to create a client connection and followed by sending a request to the Amazon Comprehend classification API endpoint, which will analyze a single document in real time using a previously trained custom model. Amazon Comprehend will then return back a payload to the user as a fulfillment result. Next, let's take a look at the overall architecture, which can be divided into two separate sections. The front end, which contains the user interface to be displayed to end users, and the back end, which contains the integration that make the end-to-end flow. How it works is that a user will make a request to the web page distributed by Amazon CloudFront, which is a content delivery network that reduces latency through caching mechanism with the web artifacts stored in the S3 object storage. The connector identity pool is used to pass temporary AWS credentials for Amazon Lex API calls and can also be used to authenticate users into the web page. With that, the browser will then be able to call the Amazon Lex API directly, which triggers the intent that integrates with a Lambda function that calls the Amazon Comprehend API endpoint, which returns a fulfillment back to the user. With all the explanation done, let's walk through an actual demo example. First, we take a look at the front end, where you can see a simple web page with an embedded chat widget where you can type anything in the chat box, which will trigger an action to Amazon Lex. In this demo, I'll be triggering three messages here. The first one being a general greeting message, such as hi, where the chatbot will respond back with its own greeting message. Next, I'll be asking some COVID-related questions, such as, is there a microchip implanted within the COVID-19 vaccine? From here, you can see that the bot responds to me with a predicted label as fake. It also gives us a confidence level that we gotten from the Amazon Comprehend model that we trained earlier. Lastly, let's try with an authentic post. You can now see that we receive a response from the model with a 99.94% of confidence level, which means that this information is predicted to be real. Now, we'll move over to the AWS console to see how you can easily configure and test this out. This is the Amazon Lex console, where you'll be able to see different action that is created for this demo. The first message is triggered by the welcome action, where it matches any greeting phrases that the bot will simply reply with a general greeting response. The Amazon Lex Natural Language Understanding, NLU in short, will try to find the most appropriate action to match the user phrase, which also improves over time. Any utterance that do not match any of the intent listed here will go to the fallback intent to handle the response. If we take a look at the second action, this is where we can have an integration option which uses AWS Lambda to pass the message for inference to the Amazon Comprehend API endpoint that contains the trained model shown in the first part of the demo. It will return a classification result that will display to the user as a response in the chatbot. Lastly, once everything is built, you can also easily test out your bot function with the built-in testing function shown in this console. Let's recap what we have learned in this session in three simple steps. First, we have the data pre-processing stage, where we use SageMaker Studio Notebook to process our training data. Second, we identify the classes for classification and provide the data in the form of CSV to Amazon Comprehend to train a custom classification model. Lastly, we implement the classifier by designing a Amazon Lex chatbot with the integration to the trained model. With that, we conclude the session. We hope that you have learned how you can easily create and use a model using our AWS AI services to classify short snippets of natural text to help warn users about COVID-19 related misinformation. Of course, the use case can be easily extended to other areas as well. For example, identifying non-COVID specific misinformation, intelligent document processing, where we can identify other data such as images. If you have your own dataset, you can make use of SageMaker Ground Truth to allow human annotators to do the labeling of the data. You can also get sentiment analysis out of text and integrate it with Contact Center to provide a self-service call center experience. For various other use cases, you can explore the use of AWS AI services to build and deploy a model quickly without any in-depth machine learning knowledge. These are some of the resources that we use in this session that can help you get started in building your own solution. You can also access a copy of the notebook used in this demo for creating your own version of this model. To improve the quality of the upcoming event and to help create more relevant content in the future, please help us to complete the session survey. Once again, thank you for joining us. If you are interested in deploying a similar solution, please feel free to reach out to our team.